Time for 3.4. This time I labeled it correctly. 3.3 I labeled incorrectly. But we get to do some trig functions this time. So I know trig is a challenge for some of you, but the trig isn't super impossible, but we can tackle it. Okay, so we're going to follow the exact same steps that we've done before. And so the first thing we're going to do is we're going to find critical points. And so critical points means that we take the derivative and find out where it's equal to 0 and does not exist. So the derivative of this is pretty simple. The derivative of x is 1. Derivative cosine is negative sine. So we've got, so I'm going to write 1 minus 2 sine of x. Notice all I did was take that negative and turn my plus into a minus. Okay, so 1 minus 2 sine of x. This always exists. There's no does not exist part because we're not dividing by 0 or anything. If this had been a tangent or a secant, we would have had to worry about where we're dividing by 0, because tangent and secant are both fractions. Tangent is sine over cosine, and secant is 1 over cosine. But this is a sine. It always exists. This is no problem. So all I need to do is set it equal to 0. So all I need to do is take y prime and figure out where it is 0. And so that means I've got 1 minus 2 sine of x equal to 0. And now I do some algebra. So let's move my 1 over there. Negative 2 sine x equals negative 1. And sine of x equals 1/2. And so now I have to ask myself this important question: where does sine of x equal 1/2? And now a lot of you have different ways of doing this. My way of doing it is to draw a unit circle and kind of think about it. Well, sine is the y value of the unit circle, right? So this is the y value of the unit circle. So that means I want to come right here to the 1/2 spot, and right here it is, and right here it is. So that angle and that angle. There are two solutions. Notice our range is between 0 and 2 pi. If our range had been bigger, we would have more solutions, because you can also go around the circle and get 2 pi plus that angle and 2 pi plus that angle. Okay, well, you have to remember, or you could type in your calculator sine inverse of 1/2, and that would give you a result. But I just know that sine equals 1/2 at pi over 6. So I know that this angle right here is pi over 6. And some of you have like a finger trick that you do, or lots of ways. This is one that we should probably know pretty confidently. So notice my answer here. One answer is that x equals pi over 6. And here, let's write that over here on this side. And then the other answer is right here. And notice that one, this is pi, so this is pi minus pi over 6. So this is 5 pi over 6. Notice I'm just doing fractions. This is 1/6 of the way around. This is half, or 1 pi minus 1/6. And so we've got 5 pi divided by 6. So those are our two numbers, and these are our two critical points. So critical point number 1 is pi over 6. Critical point number 2 is 5 pi over 6. Okay, my endpoints are pretty simple. My endpoints are just 0 and 2 pi, because those were just given to me when the problem started. So my endpoints are 0 and 2 pi. Okay, so now I'm just in the point where I'm plugging everything in. And as I plug in, I just do x equals pi over 6. So I'll do pi over 6 plus 2. Tell you what, let's write our function notation. Let's write f of pi over 6 is pi over 6 plus 2 cosine of pi over 6. And then I'll have f of 5 pi over 6 equals 5 pi over 6 plus 2 cosine of 5 pi over 6. F of 0 is 0 plus 2 cosine of 0. F of 2 pi is 2 pi plus 2 cosine of 2 pi. These are not that hard to figure out, as in, because we know that cosine of pi over 6 is square root of 3 over 2. And so this is pi over 2 plus the square root of 3 over 2. However, even that number I can't really do in my head. I can just kind of estimate in my head. So I'm just going to plug them all in my calculator and see what I get. So, so for this one, I got 2.25. Make sure your calculator's in radian mode. Remember, we always do radian mode, and that's because only in radian mode is the derivative of sine, cosine, and cosine, sine. If we're in degree mode, we get that extra pi over 180 term thrown in, which messes everything up. Okay, so let's keep trying. Let's do 5 pi over 6, and I've got 0.88, not 0.885. I'm just going to do 0.8. Yeah, I'll put a 5 on 0.886. Actually, let's just. Yeah, I can put 6. I didn't want to write it because I'm running out of space, but oh well. And now let's put 0 in. And when we get 0, oh, I should have done that in my head, right? Cosine of 0 is 1. And cosine of 2 pi is also 1, so this one is just 2 pi, which is 6.28, right? Okay, so this one is just, oh, wait. No, it's not. It's, oh, come on. Come on, Brian. Think about it. Oh, come on. So this is 2 pi plus 2. So that's, I guess that's 8.28. Yeah. Okay, sorry about that. I threw myself off because I was just like, oh, cosine 2 pi is 0. It's not 0, it's 1. And so then I had to add 2. And then I was so flustered I couldn't even add 2. So sorry about that. Even your professor has mental breakdowns from time to time. But now all we have to do is we just have to look through here and find the biggest. And it looks like this one is the biggest. And find the smallest. And it looks like this one is the smallest. And so what you see is that the max is 8.28 is the max. And this is actually, if I wanted, I could have written this as 2 pi plus 2, which probably mathematicians would like better. But 8.28 is the max at x equals 2 pi. And then the min is this value, which I could write, which is 0.886. Again, if I wanted to do it the exact way, I could write 5 pi over 6 plus, and cosine of 5 pi over 6 is, let's see, cosine of 5 pi over 6 is negative square root of 3 over 2. So that's minus the square root of 3. I think that's that number. So 5 pi over 6 minus the square root of 3 is the max, is the min at x equals 5 pi over 6. Okay, well, there we go, and we've got our answers. I think I'm not sure I did. Okay, hold on. 5 pi over 6 minus. Did I get the right answer there? Square root of 3. Okay. Oh, good. Okay. I'm sorry. My calculating brain has turned off. I've done too many of these videos today. But there you go. Hopefully these are making sense. You get to do a bunch of homework problems. As you're going through the homework problems, here's how I would judge your success rate. If you are able to find the derivatives and find where they're equal to 0, then that is like a really good start. And then doing the algebra. So if the algebra gets tough, that's okay. That's normal. Keep pushing through it. Keep working on it. So where most of you will get stuck is in this algebra section. But keep pushing, keep working, and we'll be successful. Okay, see you in study hall hours as we work on these problems, and see you later.